All right, this lesson, which I guess currently is in lesson Unit 3B, which is our quadratic applications unit, is going to it's going to touch on functions, but then it's mainly on domain and range. So let's just begin by talking about a relation. A relation is basically when two numbers are connected together. There is a relation between the two numbers. And the very first relation that I want you to be familiar with is something called a mapping diagram. And it's very easy, very simple, and all it is you'll usually see an oval for the x's or for the inputs. You'll see an oval for the outputs, and then you will basically see a line that makes the connection or shows the relation. So in this case, we actually have 0 connected to -2. If I represented those as points, it would be 0, comma, -2. 0 is also connected to 1. 1 is connected to 2. 2 is connected to 1, and 3 is connected to 4. So I have 1, 2, 3, 4, 5, and I have 5 points. This is the relation of a mapping diagram. These are coordinate pairs, and then I actually have them as points on a graph. Okay, so we actually can represent the same connection of numbers, x's and y's, on mapping diagram, coordinate points, and graphs. So like if I look at 0 up 1, that's that point right there. 0 down 2 is that point right there. 1, 2 is this point right here. 2, 1, and 3, 4. So all of those points are related. Then that's it. There's just a connection. Now we want to actually make sure before we leave this unit that we really know what a function is. Because a quadratic is a function. The x squared is a function. All right, a function is a relation in which each input has only one output. So basically every x has only one y. And notice that I did not say every y has one x. So it's not necessarily a two-way street. This bus is only really going one way. Every x can only have one y, okay? So every x, it's like you can't repeat it. If I input x into an equation, okay, and I get an answer, I should not be able to go into the put the same input into it and work it out and get a different answer. There should only be one output answer for every one input answer. Okay. Now that doesn't mean that I can have a different equation and you input different numbers and get the same output. So you can repeat y's, you just can't repeat x's. Okay. Now you'll find that we're going to talk about that a little bit more. And here's another way to look at it. Again, on the left, this is a relation. These numbers are connected. They have a relationship. In my mapping diagram, though, you'll notice there's only one line coming from -1. So -1 is connected to 2, and that's the only line. So -1 only has one output. 0 has one output. Now, it does not matter that it went to the same output. Remember, you can repeat your y's. You just can't repeat your x's. So it's okay to repeat the 2. It's just not okay to repeat the x, and I did not repeat an x. 1 is related to -3, 2 is related to -2, and 8 is related to 3. Again, just like before, these are my coordinate pairs that go with those points that are represented in the mapping diagram, and over here I end up with the graph. And so every point that's represented, those 5 points are somewhere on the graph. Again, 0, 2, okay, and then I would have, looks like -1 up 2. I have 1, -3. I have 2, -2. And then I have 8, 3. All right. Again, every input, okay, has one line, one output. It's connected to one output, connected to one output, one output, one output. Every x can only have one y. If we jump back a screen and we pay close attention, with the first relation that we looked at, is this a function? Is this a function? Have you made your choice yet? I hope that you said no, it's not. And what messes it up is we have actually repeated the 0 as my x value. And 0 gave me one answer of -2 and a different answer of +1. There's also 2 lines going from 0, and you cannot have that and it still be a function. So every x can only have one y. So this is still a relation. It just means that things are connected. But when you get down to the nitty-gritty of what it takes to make a function, it's not a function. All right. There's also ways to check. Okay, we've talked about each input having only one output. There's also a visual way to just look at a graph quickly and say, yes, it's a function, or nope, it's not a function. And that's called the vertical line test. And here's what it really says. If you can draw a vertical line, which is up and down, across your graph, and it only touches the graph once, then it's a function. If you find that it crosses it more than once, then the answer is no. All right, so I'm going to look at the next graph. Let's see. Okay, so here's a summary real quick. Function, for every x, there's only one y value. That means you can't repeat an x, but you actually can repeat y values. Vertical line test. If a vertical line can be drawn on a graph and only touch the graph one time, then it is a function. Now, you do not have these two quick graphs on your paper, but it's a quick visual way to actually see if we understand the vertical line test. Do you see the blue line going across the screen? Okay. And so if you ask yourself, does it pass the vertical line test? I want you to imagine drawing a vertical line anywhere. So right there, if I go up and down one time, come over here, it touches once. Come here, it touches once. And if I go across the graph anywhere and I only do vertical lines, guess what? It only touches once. This one, yes, is a function. Visually, it passes the vertical line test. This one, though, if you'll notice, do you notice how it kind of crosses back under itself? That's going to probably make it not be a function. Now, if I did my vertical line test on the end, yeah, it's okay. It's still okay. It's still okay. Uh-oh. So you have to actually check the vertical lines across the graph. And as soon as you see a spot where it would not touch just once, this one happens to touch twice when I did that last vertical line, and that means it fails the vertical line test. It fails the test. It is not a function. So the first one passed the test, the second one failed the test. Again, that's just a quick visual of being able to check it. If I jump back my screen back to the very first, okay, this is the very first. If we happen to look at the original graph, even though these are just dots and not a whole connected graph, do you notice that this dot and this dot are straight up and down from each other? If I did a vertical line, it would actually touch 2 points. So this one, if we go back and look, it also fails the vertical line test. Okay. We had already looked and saw that it had 2 outputs for each input, which is the basic definition, and then of course it fails the vertical line test. So that was our touching on a function. Now we're going to jump into the meat and bones of this lesson, which is domain and range. Domain is the set of all the x values. If you graph it, it's going to be across the x-axis, and if you want to connect to science class, we always call that the independent variable that's graphed there. In science, a lot of times time is the variable that you can control. You would measure things perhaps in science. Like every 5 seconds we might measure temperature, or every 10 seconds we might measure distance if we were rolling something. And we would put that on the x-axis, and it's called the independent variable because you can control the time frame. It is also the input or inputs of the function. Those are the numbers that go into the function, and what comes out is the answers or the y values. The word range, these are the y values. It is the dependent variable. These are going to be graphed in science class on the up and down y-axis. So if I was doing a science experiment, and so after every 10 seconds I measured the temperature, then I controlled the temperature. I could control if I measured it every 10 seconds or maybe 30 seconds or even every minute. But then after I did that, then I would measure the time or temperature. Then I would measure the distance. And so those values would be the dependent variable. These are also called the outputs in math class. Okay. All right. Let's talk about the first example. Example 1 says write the domain and range for each of the following. These are going to be very simple examples. I'm going to use a capital letter D, and I'm going to use a colon. Then I'm actually going to use a brace. It kind of looks like those squiggle lines. And I'm just going to list every single X value that's in the domain. This is my X, this is my Y. So that means X is 0, Y is 3. So if I make a list of the domain, 0 is in my domain, not the 3. 2 is in my domain, not the 6. 4 is in my domain, okay, not the 12. So that is my domain, okay. What are the values that's in my range? I will use an R for that, and I'm going to use a brace, okay, and I'm just going to list. There's only 3 points in the table, so there's only going to be possibly 3 numbers in the range. 3 is a Y value, so it's in my range. 6 is a Y value in my range. 12 is a Y value, so it's in the range. Is everybody understanding? Domain is a set of the X's. Range is a set of the Y's. Okay, the second example, oh, I'm sorry, I actually overlooked example number 1. I jumped straight to example number 2. My bad. The domain in these ordered pairs, there's 1, 2, 3, 4. 4 different points, possibly 4 X's and 4 Y's. Possibly. Okay, my domain, 0 is in the domain. And if I did my range at the same time, my range would actually have 2 in it. Okay. 1, -5. 1 is in the domain, and I believe -5 is in the range. 2 and 8. Well, 2 goes in the domain, and 8 goes in the range. And last point, 3 is in my domain, and 10 is in my range. Okay. And when I look, I end up having 0, 1, 2, and 3, 0, 1, 2, 3, and then I had 2, -5, 8, and 10, 2, -5, 8, and 10. I'm just making a list. I'm using braces, separating them with commas. Pretty easy, pretty straightforward. Okay, we want to make sure we have a good foundation, that we understand what it is. All right, moving on to example 3. This is a mapping diagram. Again, in the mapping diagram, all we have is we have ovals or circles that have X's usually in the very first circle, Y's separately in the second circle, and then you actually have this line, or in this case an arrow, connecting which number to which number. Okay. Does everybody kind of see that all of these numbers would be in the domain? 0, 1, 3, and 9. Put braces around those. All of these numbers would end up being listed in my what? Hopefully you knew that was range. -5, 4, 8, and 14. Now at this point I hope that you're thinking, boy, this is too easy to be math 2. And it kind of sort of is. It can be that simple. If you have just a few points, it's super, super easy just to list every single point. I can easily list 3 numbers in a list, or 4 numbers in a list. But I do have a question for you. Here's the question. If I were to put a solid circle on the 1 and a solid circle on the 2, and then I drew a line from 1 to 2, what I'm trying to do is I'm trying to actually highlight or shade in all of the numbers between 1 and 2. Okay, so my first question is, can we write down every number marked on the number line? It's just between 1 and 2. Is it easy to do that? If I could, and again, this is the X direction, because that would be like the X axis. We're not looking at the Y, we're just looking at X right now. I would be talking about the domain. So you might be thinking, well, yeah, that's not that many. We could see that'd be 1. And then obviously 2's in there, but aren't there some numbers in between? Okay, so somebody thinks, well, but 1.1's in there, 1.2's in there. Okay, yeah, 1.3, 1.4, 1.5, 1.6 in there, 1.7's in there. So it's getting a little bit long. There is a lot of numbers. Okay, is that all? Wonder if that's all. Let's see. Then I actually can think about, well, I did give 1 decimal. What if I wanted to list 2 decimals? Could I list up to 2 decimal places every number between 1 and 2 on the number line? Ooh, let's see. That'd be 1.01. Wow. 1.02, 1.03, 1.04, 1.05, 1.06. Oh gosh, this is going to take a long time. Well, I probably could do it though. I probably could write them all down between 1 and 2 if I took 2 decimals. Oh no. But what if I can do 1 decimal and I can do 2 decimals, can I do 3 decimals? Oh my goodness, 1.001. That's actually thousandths. No, actually that's 10,000th place. That's thousandths, so I was right the first time. That's 1 1,000th. Okay, 1 and 2 1,000ths, and 1 and 3 1,000ths, and 1 and 4 1,000ths, 1 and 5 1,000ths. Oh my goodness. I wonder if it really is possible to list every single number between just 1 and 2. Because if I can go to 3 decimals, there's a chance I could even go to as many as, what, 4 decimals? That's 10 1,000ths. Ooh, man, I would be writing for forever. You know what? If I could go that, I could go even 5 places. Oh, Lordy. Nope. I don't want to do that. I think it is not possible to write down every number marked on the number line, because no matter how small I could write them down and get my list finished, there would be a whole nother list of numbers to write. I'm going to have to figure out, you know what? No, you can't do it. You cannot list every number marked on the number line, even between like 1 and 2. There's just too many, because you could break them down smaller and smaller and smaller. So that leads to a question. We're going to have to figure out some way to talk about how do we list, or how do we note all of the numbers between 1 and 2. Well, I do want you to go back and remember this symbol here is actually the less than symbol. Okay? Kind of look like it kind of remember that it does kind of make something like an L. Okay? Kind of looks like an L. So we know that's less than, which means this direction pointing forward is actually the greater than sign. Okay? So what I want to do is I actually want to say, you know what, if I start at 1 and I do an arrow, I can actually say, you know, that's all the x's that I'm looking at. Well, they're equal to 1, but they're also greater than 1. So you actually say greater than or equal to 1. All right? But then that would be way too many numbers, because it would go over to 2, then past 3, then past 4. So then I'd have to have a second one starting right here. Okay, I'll use a different color. Starting at 2 and say, you know what, let's go back. So it's actually all the numbers starting at 2, so this would be x's, starting at 2, and they're actually equal to 2 because it's a solid circle, and it's all the numbers less than. But in order for me to talk about just those group of numbers between 1 and 2, it actually has to meet both of these criteria at the same time. It has to be greater than 1 and less than 2 at the same time. Okay? So is there a way to write that? And yes, there is. Here's how you do it. If I were to start with this one, okay, I'm going to say x, and I'm going to keep it pointing toward the 1. Oh, wrong way. Penny, penny, penny. All right. If I put my x in the middle, and I say less than or equal to 2, because that's actually what this one says. And on the other side, and it makes sense because this is my bigger number, so it's going to be on this side. And then I take this one right here, and I put a 1, and I put the x, and I notice that my symbol's pointing toward the 1, and then I have down here, now it's going to actually be backwards, so I'm going to have to flip it. It turns out that I actually have my smaller number on the left, my bigger number on the right, and I've actually got one combined inequality. This is a combined inequality, and here's what it says. Okay, inequality means they're not exactly equal. In this case, they are equal to or less than. Okay, this is actually a way that we use to designate something called between. This is my favorite thing, my favorite inequality to write in all of Math 2, and you're going to write it several times. That's called between. This says all of my x's are between 1 and equal to 1 and 2 and equal to 2, okay? Between. It's basically taking two inequalities and putting them together. And let's make some observations here. Number one, do you notice that both of them go backwards, backwards, or less than, less than? Notice that the X is the letter in the middle, and X happens to be the direction that I was doing. I was going across the graph in the X direction. I had my smaller number on the left, my bigger number on the right. So that's actually setting us up to understand what we're getting ready to do next. All right. Finding the domain on a graph. When the domain is a set of the x's, we're going to talk about x's farthest to the left to farthest to the right. Again, farthest one to the left to farthest one to the right. Remember how we talked about that smaller number and the bigger number? Range will be the y's, so we're talking about the lowest number on the graph up to the highest spot on the graph that's used. So you'd be lowest number to highest number. Just kind of keep that fresh in your mind. Okay, don't need that slide anymore. All right, I believe on your notes, this is a solid circle and a solid circle. I need to mark that in there permanently. We're going to talk about the domain. Notice that in the domain, they have already got us set up to do the domain, and they've set it up for us, at least part way. Okay? Notice that we have what letter in the middle? X. And that's important because X is between and X is in the domain in the X direction. It's a set of the X's. Notice that the signs go less than, and this one already has it equals and equals, and we'll talk about what that means. Okay? If you have the equals, then one thing that you can look at is right here. If it's less than equals or greater than equals, that means the endpoint is included. That means that if you mark it on the number line, you actually touch at that number. You can include that number in a list, okay? And it is marked with a closed circle, okay? All right. If it does not have an equals, all right, it does not have an equals, it's just less than or greater than. That means if you make a list, you cannot include that number. So if you have an open circle on a 2, you cannot put 2 in the list. It is not included. You could put 2.01 in the list because that would be just barely bigger than 2. But 2 would possibly be the first number to consider looking at. So there is a difference between not included and being included. Okay? All right, again, they've set us up. So we're kind of training you today to do your domain and range. All right, first thing I want to do is I'm actually going to take note of whatever this endpoint is. This, if you start at the center, you're going to come left 5, down 3. Left 5 is -5, down 3 is -3. Up here, I'm going to come over 3 and up 3. And I'm going to pay attention to the fact that that's an X, that's a Y, this is an X, this is a Y. So the first thing I'm going to say is, it looks like this is a solid line. So it looks like every X value, and I'll just kind of mark it off, between here and here is used. And it looks like the first X value that's used is -5. So I'm going to put that on the left. That's the leftmost X. The number farthest to the right X is +3. And there is already an equals there because it actually does have a solid circle. It does touch at -5. It's included. It does touch at 3. It's included. We've just finished our first domain. Okay. And again, this is for a function that is so continuous, that has so many points, we cannot list all of the x's. Now let's do our range. Okay, range. Range is lowest to highest. Range. So now I'm actually looking at y values. What is the lowest one? Well, if I imagine coming up the y-axis and I ask myself, what is the first y value that's actually graphed on this picture? Looks like the first y value goes as low as -3. Right there's -3, and that's the y value that I use. So -3 would be on the left. Looks like it goes as high as +3, and then it stops. +3 would be the biggest y value. Again, we want to try to train you today. So look, y was in the middle, less than, solid circle, so equals, -3 to +3. That is actually how it's written, and that's what you say. It's every y value from -3 to +3, including -3 and +3. Okay, That's my range. And then there's a little question, let's not forget, is this a function? Do you remember the vertical line test? If you could imagine a vertical line coming down anywhere, does it pass through the graph once? Yes, touches once here, once here, once here. Anywhere it would touch once. So is this a function? Yes. So it's a little bit messy, but that's how we do domain and range of a function. All right, let's look at the next graph. I'm noticing in this graph, I see a solid circle up high, but a clearly open circle down low. All right, one more time. If it's solid circle, we're going to be talking about less than with an equals under it, or maybe greater than with an equals under it. If it's open, we're going to use less than or just greater than with no equals. Okay, and you are just putting one equals. Okay, that symbol's like less than or equal to, and what they do is they blend it together and call it less than or equal to like that. All right. It's easiest if we go to the graph and plot the points. So starting at the center, I'm going to come -6 up 4. That's -6 up 4. And down here down low, we're going to go over 6 and down 6. All right. First thing I want to do, I want to imagine starting over here, kind of sweeping my hand across the x-axis. What is the first x number that's used? Okay, I'm going to mark right here. Looks like the first x number that's used is a -6. They did not get me set up this time, but I know if it's domain, I should put x in the middle. Remember we said we're going to train you today. It's always less than on one side, less than on the other side. So less than, less than. Now I'm ready for my number. The number for this one is -6 on the left. And how far does it go? Well, if we continue going across the graph, what is the last x value that's used? It looks like it is, the last x value looks like it is 6. So it looks like I'm going from -6 to +6. My x is in the middle. My less thans are both going backwards. They both point the same direction. This time I got to look. Remember this one up here? This one was solid. This 6 can be included. I need an equals under it. The 6 down here, open circle, not included. I do not put anything there, so you leave it. Do not put anything next to the +6. All right, now we're ready to do our range. Let's kind of clean it up a little bit. Let me grab a different color. Remember, we're going to sweep up from the lowest to the highest, and it looks like the first lowest number, it's almost like you put a box. Since my graph starts and stops, almost like I can put a box around it, it helps me focus on the numbers. The first y number that I believe we use is -6. So I'm going to start with my y in the middle, less than, less than. Everybody should start with that. That's the setup for between. And again, the lowest y value right over here, -6. I notice that that is an open circle, just like it was a minute ago for the same point. That open circle is still open. I do not put an equals right there. Do not put an equals. Now, let's continue on up. Let's go on up the graph. So if I go on up the graph, what's the last y value? Well, the last y value looks like it crosses at +4. Okay, +4. That is still a solid circle. It was at the beginning. It's still solid. So on this 4 side, we need to put in an equals. That is my domain and range. We wrote it all ourselves from all of the beginning. It didn't set it up. We set it up ourselves. The domain and range must always go from smallest to largest when you have the endpoints. Is this a function? The answer, yes. If you tried to do a vertical line anywhere, it would only cross one time, anywhere. That makes it a function. It passes the vertical line test. All right, next one. First time we've done a graph, okay, that it has arrows. Okay, what do arrows mean on the ends of a graph? Well, I hope you know that that means that it continues forever. And if it continues forever, what do you call that? What is the idea that numbers will get bigger and bigger and bigger forever? Well, they will continue forever to infinity. So that's what we symbol. It looks like a sideways 8, and we call that infinity. What I want you to do is I want you to understand that this graph will continue going down in this direction forever and ever. So not only is it going to get farther down, it's also going to get farther left. So I want you to learn to take an arrow and to split it into its different parts. This one's going in the X direction. This one's going down farther in the Y direction. This arrow over here is going to keep going down in this direction forever and ever. It's going to keep going farther to the right in the X direction, farther down in the Y direction. Now the next question is, where is it going to? Conceptually, where is it going? Well, if I look at my X's, this is -2, -4, -6, -8, -10. This would be -12, -20. It keeps getting farther and farther. Looks like it's going to infinity, but it's going to the negative numbers infinity, or I'm going to call that negative infinity in the X direction. What about on this side? Okay. These numbers are 2, 4, 6, 8, 10, 12, 20, 30, 50, 100, 150. They're going to keep getting more positive and more positive to infinity, and they're going to continue forever. So notice that we have negative infinity on the left, positive infinity on the right. All right? Now let's talk about the arrows going down. Okay? Notice that if you go down, okay, -2, -4, -6, -8, -10, -20, -50, -100, keeps going, it keeps going. It's going to go down to infinity also, but these are negative numbers. So in the Y direction, it's going to negative infinity. And this one's going the same way. This one's going to negative infinity in the Y direction, because the arrows on both of the Y's are pointing down. All right, my domain. Let's get ready and write it. I know if it's domain, I should put X in the middle, and to set it up, it's less than on both sides. They both go the same way. They both go less than. When I do range, it's Y's, both go less than. So I know I'm setting up myself to do my domain. All right, I'm looking for things to put on the left and the right, smallest to largest. If you follow yourself coming in, this time, what is the smallest number we're coming from in the X direction? Remember, those numbers are going to continue forever and ever and ever. They're going to get more and more negative, and technically they're getting more and more smaller or smaller. So I want you to understand that they're actually coming from negative infinity, and then this graph is going to continue, okay, all the way across here, and then it's going to keep going to positive infinity. Does everybody see that? For the first time, we actually have arrows pointing from negative infinity to positive infinity. And in this case, if we ask ourselves this question, is there any X's that are not used? The answer is no. If I ask myself, if I go to 0, 0 used, yep, 0 up 4 is used. If I go -1, is -1 used? Oh, negative up and like so many is used. -2 and up, so many, yep, there it is. -3, yep, there it is. -4, yes. -5, yep, there it is. Every single number. What if I go way out here to -10? Well, if I go down far enough, the graph is going to continue. I will actually have a value. And the same thing happens here. If I go over here to 6, well, if I go down far enough, that's like 6, -4. There are going to always be some X value with some Y value marked on the graph. Every single number. So for the first time, I want you to write this down. All real numbers. You can write the word out. You can write the symbol. I don't mind if you abbreviate. All real numbers. Okay? That is a phrase that means the same thing as negative infinity to positive infinity. Negative infinity is where it comes from. It's going all the way to the bigger and bigger and bigger positive numbers. Every possible number you can ever think of is used somewhere on this graph. X, that is. So there is actually one symbol, and this is the symbol that actually means all real numbers with one letter. It's universally known. It's like it's got a double beginning, a double stick in the front, and this right here is called all real numbers. So technically, if you see this on an answer, that means all real numbers. If you see the phrase, this means all real numbers. And if you see negative infinity to positive infinity, that means all real numbers. So all three of those technically mean the same thing. All right, now let's talk about range. Okay, let's talk about range. I have it set up. And I do have arrows. This one, though, will not be all real numbers. And here's the difference. If I trace or ask myself, remember, I want you to come up from the lowest. And if I'm thinking down here, remember these arrows that pointed down? These numbers are going to be as far down as I ever want to go. So if I imagine sweeping my hand up the y-axis, every y number is used, every y number is used, every y number is used, boom, till I get right here. Then it stops. There's nothing above what y number. Nothing above what y number. The y number is 4. So in this case, where are we coming from? We're coming from negative infinity. How high do we go? Well, we stop at positive 4 on the y's. Notice that those arrows go in one direction, and we have infinity in one direction. Okay? One side, infinity, one direction, infinity. The other one has a number because it stops. So this one comes from as small as you want to think about to only getting up to 4 and stopping. Is this a function? Answer is yes. So it looks different. It's the first time we've talked about infinity. So we're saying basically every answer is less than 4. Oops, almost forgot something. Does it look like it touches right here at 4? Does it look like it comes up and actually touches the 4? It really does. If it doesn't look like it's going to touch the 4, it'll either be very much below the line or it's going to have an open circle. I do need an equals right here. Another way to write this is to say, you know what? That's actually all the y's. Now, are these y's below 4 or above 4? They're actually below 4. What symbol would mean the same thing as below 4? I think that is less than 4, okay? Which is exactly what this part means, okay? That is probably the only part that you would see on a multiple choice because it's understood that the smallest would be, as small as you want to think about is infinity. Okay, let's go to this one. This would be a good one for you to try. So if you want to try, pause the video, and I want you to see if you could possibly start with x and y, less than, less than, less than, less than. See if you can find the numbers. See if you can figure out if some of them have an equals. I will tell you, I noticed that this is farthest to the left. All it goes over, this looks like farthest to the right. This looks like lowest to highest. You might want to plot the point. So like, what's the point here? What's the point here? And then see if you can find out which numbers you need to focus on to fill in your domain and range and yes or no function. Pause the video, see what you can come up with on your own. Test yourself. All right, what did you come up with? Did you successfully answer the questions for domain and range? If you didn't, just pay attention. If you look at your x's, it's actually, if you put a box or you kind of start it, the first x value is noted to be -1, which is where it crosses up here on the x-axis. -1 is right here. It goes as far as +7. That's where 7. That is a closed circle. So because it's a closed circle, you do need an equals. On both sides, every circle is closed. So I'm going to have equals under everything. Same thing with the bottom. If I look at how low does it go, okay, it goes as low as -9. That's a y value. So we're looking at -9 on the y's, and it goes as high as +1 on the y's. So I'm looking at where it crosses the y-axis, here and here, and of course it crossed the x-axis here and here. So that's just a visual way. If you kind of mark it off, think about farthest to the left to farthest to the right, lowest to highest, you should get the same answers that we got here, and of course that should be -1 is the highest. Again, all of them needed equals because it did have solid circles, it did touch at those points are included. Function is no. Hope you can see if you draw a vertical line, it does touch more than once. Okay, this is another good example for you to try. Pause the video. Give it a try. Hopefully you know x in the middle, y in the middle. You remember how to write the direction of your inequalities? Yep, less than, less than, less than, less than. That's a good way to start them all. Then you can kind of focus on what your numbers are. Okay, this one starts and stops. So if you want to think about, you know, it does have open circles, it has closed circles. Okay, you can focus on lowest to highest. You might want to find your points. Those are helpful to show you the numbers. And pause the video, see what you come up with. Okay, we've unpaused the video. Did you successfully get -6.8, +7.2? And did you notice that in this case, I have my -6, my +7, that's my numbers here and here. The 7 is closed, so I only need an equals under the 7. The -6 is open, so I do not need an equals. And if I do my range, I go up. The lowest number I touch is 2 in the Y. And the highest number I touch is 8, from 2 to 8. And again, 2 is down here where it's closed. So where it's closed right here, I have my equals next to my 2. I do not have an equals at the 8. It didn't actually ask, but I hope that you could easily tell that, yes, this is a function. And this would be the last one. I'm going to give you about, well, I'm going to take some time and ask you to pause the video and see what you could come up with on your domain and range. I'll just make it bigger up here. X in the middle, less than, range. Y in the middle, less than. Did you break down your arrows? That's the first thing I'd like to see you do. If you see arrows, break them down into positive and negative. If you see arrows, there's going to be infinity in some directions. And did anybody get that in the X direction, we actually have an arrow going backwards and an arrow going forwards? So that actually would be -infinity to positive infinity. And just to make sure that I've said this, there is no equals on infinity. Ever, ever, ever. No equals on infinity, because you actually cannot tell me what value infinity is. It doesn't have an actual numerical value. It's an idea of numbers that get bigger and bigger. All right, same thing in the Y direction. I'm going to come from as far down, I'm going to actually come up from the negative infinity numbers in Y direction, and I'm going to keep going up. So I'm coming from negative infinity, and I'm going to positive infinity, no equals. Now, what's another way to say this? Well, negative infinity to positive infinity is all real numbers. Negative infinity to positive infinity is all real numbers. Or if I really want it to be super abbreviated, I could just simply say all real numbers, and that's universally known to mean the same thing. All right.